Hi everyone. In this lesson we want to talk about solving trinomial equations when the leading coefficient isn't 1. And in particular we're going to be focusing on solving these by factoring. So notice here's a trinomial and it's an equation it's set equal to 0, and the way that we would go about solving that is by factoring. Notice there's also a common factor here of n. Let's go ahead and factor that out. And then I have to continue factoring this trinomial. I've got n. And I'm going to have to break this apart as two binomials and try and figure out the right factors that will allow me to factor that. Alright, so unless this number in the middle is quite large compared to these, I wouldn't start with 8n times n. I would start with 2n times 4n. And then let's think about the factors of 3 that I would need to combine in just the right way. The only way you get 3 is 3 and 1. Notice if I were to put a 3 right here, that's going to be too big, right? Because I'm going to get 12n and 2n. And because these are all plus, I'd have to add those. And 12 and 2 are going to give me 14. So let's turn it around. Let's try the 3 over here and the 1 right here. So that would give me 6n when I do the outers. And 4n, if I do 6n and 4n, that would give me 10n. Notice again that because the signs here are plus, these both have to be plus down here as well. Now always double check your factorization. It's so easy to make a mistake in this. So multiply the first, that's 8n squared. Do the outer ones, that's 6n. And the inner ones are another 4n, so you combine those. 6 and 4 makes 10n in the middle. And 1 times 3 is 3. Alright, so now that I have factored that, I have three numbers that are multiplied together to give me 0. Either the first number has to be 0, and don't forget that. That's the most common mistake I think students make when solving a problem like this. Or the second number could be 0, or this third number, 4n plus 3, could be 0. So n equals 0, that's solved right there. Here I have to go a little further. 2n would be negative 1, and n would be negative a half. Or here, 4n would be negative 3, and n would be negative 3/4. Okay? So those are my three solutions by factoring. Here's another example where I have a product here equaling 10. I don't have a principle of 10 products, things that multiply to give me 10. It has to be 0 on this side. So first thing I need to do is multiply this out. And then go ahead and bring the 10 over so that I do get 0 on one side. Okay, and again this number in the middle is quite small compared to the 21 and 10. So I really don't want to try 21 and 1 for 21a when I factor this. I'm going to go with 3a and 7a. And let's try the factors of 10. Let's try 5 and 2. And right away, I notice if I put a 5 right here and a 2 right here, that would give me 15a and 14a. And if I combine 15 and 14 in just the right way, it's possible to get 1a in the middle. Especially I notice that this, since this is a negative 10, the 2 and the 5 are going to have to be different signs, right? Which means if they're different signs, I'll be adding one of these and subtracting the other one. So notice if I put a plus here, that'll give me a plus 15a. And I want a plus on the biggest of those two factors of the 15 and 14 because I want it to end up being plus in the middle. Then let's put a minus right here. So I got 15a minus 14a is 1a, and then the negative 2 times 5 is negative 10. Alright, so let's go ahead and set each of those equal to 0. I'll either get 3a minus 2 equals 0, or the 7a plus 5 equals 0. So 3a is 2 and a is 2/3. Or the 7a would be negative 15 and a would be a negative 15/7. Okay? Okay, here's another way to pose the same problem, just using different language. It says to find the zeros of the function g of x equals 6x squared plus 13x plus 6. Now the zeros of the function are the x values that you plug into the function to make the output be 0. So I want to solve where 0 is equal to 6x squared plus 13x plus 6. And so it's just another quadratic equation that we'll solve, hopefully by factoring. So let's see if we can go ahead and break that up as two binomials. Again, I would try the 2x and the 3x, the inner factors of 6, as opposed to 6 and 1 that I call the outer factors. And then again, when I notice both of these are plus right here, I'll try the factors of 2 and 3 again. I don't want to put 2 here. Remember, if I put 2 here, there'd be a common factor of 2, but there's no common factor of 2 out here. So let's try putting a 3 here and a 2 here, and when I do that, I notice I've got 4x from the outers. It's 9x for the inners. That does make 13x. If I put plus for both of these, which that has to be because those are both plus, that works. I've got 6x squared. I got a 6x or a 4x here, and a 9x here makes 13x, and then the 3 times 2 for the last ones make 6. Alright, so let's set each of those equal to 0. I get 2x plus 3 equals 0. So 2x is negative 3, and x is negative 3 halves. That's one solution. That's one of the zeros. Or from this factor, I'd have 3x plus 2 equals 0. So 3x is negative 2, and x is negative 2/3. That would be the other 0. So there's actually 2 zeros to that function. Here's another way we can pose a similar problem, same problem, just different language. It says here's a function h of x, and we're asked to find a such that h of a is negative 32. Now be very careful that this problem does not say find h of negative 32. Okay? So let's write a big danger here. First time students say this, sometimes they're confused. It does not ask for h of negative 32, right? H of negative 32 would say, you know, what's the output when I plug negative 32 in? But that's not what it's saying. It's saying find the input, find the a value that you would plug into this function so that the output's negative 32. All right? So h of a, if I plug a into this, I'm going to get 4a minus a squared, and I want that to equal negative 32. So you see, this really results in the same sort of problem that we have been doing. I'm going to solve this equation now, right? I can solve that. What I'll do is I'll put 0 over here on the left hand side. I'll take the a squared over here, that makes it positive. I'll bring the 4a over, that's negative 4a, and then I can go ahead and solve that by factoring. All right, a and a, and the factors of 32 that I want are 8 and 4. I want the middle term to be negative, so I'll put a negative on the big factor 8a and a plus on the small factor 4a. So that gives me a negative 4a in the middle, and then the positive 4 times the negative 8 is negative 32. So if I set each of these equal to 0, I get that my a value I'm looking for is either negative 4 or 8. Okay? So let's just check that. If I were to plug 8 in here, I would get 4 times 8 is 32, and then I'll subtract 8 squared, which is 64. Well, 32 minus 64 does give me an output of negative 32. Or if I was to plug negative 4 in, I'd get negative 16 here, and then I'd subtract 16, so negative 16 minus another 16 is also negative 32. So it really does work. Okay? Last problem we want to look at, another way of posing a problem that results in the same sorts of problems we've been working on. Here's a function, it asks us to find the domain. Well, remember that at this stage in our algebra, the only domain concerns you really have to worry about are number 1, don't divide by 0, and number 2, don't take square roots of negative numbers. So here I have the potential to divide by 0. So because I have this algebraic expression in the denominator, so I just say to myself, I don't want that denominator to be 0. So I don't want 2x cubed minus 2x squared minus 12x to equal 0. So I just have to solve this equation, and that's similar to other equations we've solved. First, factor out the common factor. And then go ahead and factor the trinomial that's left. Okay, double check, make sure you didn't make any mistakes, and then just set each of these factors equal to 0. Either the first number 2x is 0, that would make x equal 0, or the second factor, if you set that equal to 0, x would be 4, or this third factor, if you set that equal to 0, x would be negative 3. Okay, that's what I don't want to happen, right? If I plug in 0, you can see I'd get 0, 0, I'd get 0 in the denominator, all right? So my answer here, the question is the domain is going to be the set of x such that x does not equal 0 or 4 or negative 3. Okay?